Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here unit number 5, types of flow. So in that content we are going to discuss here the flow through pipe in a series or flow through size or flow through pipe in a compound pipes. So either we can say series pipe or we can say compound pipes. Also we will discuss here the parallel pipe and HGL, that is hydraulic gradient line or total energy line. So these are the point we have discussed over here. Uh, in previous lecture, we have discussed regarding the minor losses. So different minor losses is there, and we are computing for different losses in a pipe. Now we are moving for the first point, that is flow through pipe in a series, or can say flow through a compound pipes. So in that case, the pipe in series or compound pipe are defined as the pipe of different length, different diameters are connected end to end in a series that forms a pipeline as shown in figure. So this is there are two tanks, A tank and B tank. So here placed here, and it is separated by a distance by three pipes. So actually this is three diameter of different pipes, D1, D2, D3 different pipes, and having length L1, L2, L3 also different lengths. So particular that pipe number 1, pipe number 2 and pipe number 3 having their different frictional losses, or you can say friction resistance. So that friction resistance is F1, F2, F3. So these are the three different friction factors also available with us, and this separated by these two height, that is why A and B, that height is separated by capital H. So here we are considering this L1, L2, L3 are the length of pipes for 1, 2 and 3 section of pipes respectively. Similarly D1, D2, D3 of different diameter pipes 1, 2, 3 respectively. Similarly for V1, V2, V3 also different velocities for 4 through 5, that is 1, 2, 3 respectively. Then F1, F2, F3, that is coefficient of frictions. So this coefficient of friction is depending on these different parameters like different materials, different lengths, diameters. So according to that we have to know that the F1, F2, F3. So this is also different for different pipes. Then capital H, this difference between the water level in two tanks. So this is denoted by capital H. So this height is called as a capital H. Okay. Then next we move for the considering with there are two methods. One is the major and minor losses considering, and another is neglecting the minor losses. So in first case we will discuss major and minor losses. Means what? You are considering the major, that means friction losses, and minor means loss of head due to enlargement, contraction, then obstruction, then bend in pipe, otherwise pipe fittings. So these type of losses we are considering the minor losses. So already we know that the classification of the losses. So first is major, second is minor. Major means friction loss, and minor means all these different types, sudden enlargement, sudden contraction, sudden bend in pipe. So many losses is there. So in this minor losses. So first of all we look at the discharging passes through a pipe, which is same because Q is same from point A to point B. That means that pipe at initial section, that point 1 to 3 is same. That's why we can write Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. So only changing the diameter size and that length size. So that's why we can write as Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. Now we computing for the difference between the two tank level, that is H is equal to. So this H is equal to, we are computing with major and minor losses. So first of all we look at the when the water enters into the pipe, that is called as entrance loss. So this entrance loss is indicating by HI. Okay, we considering the HI plus for this pipe is having different length and diameter, so that's why the friction will takes place. That's why I can say HF1. So this is called as friction loss. So this friction loss is denoted by HF1. So here we denote it as a HF1. Similarly we do then water enters into the second pipe. So that time the larger diameter is converted into minor diameter. That means this D1 is maximum and D2 is small. So that time the loss is called as contraction. So we can say contraction. So contraction means HC. So here we write HC. Here we write HC plus this loss. This loss is called as again this pipe is long length. That's why we can take the friction loss. That is friction loss is at second pipe. That's why I can write HF2. So in HF2. So here already we written HF1 for first pipe. So that's why we write for HF2. Now next the diameter is small, right, diameter is small. After that it should be increasing. So that time this loss is here, this loss is called as here, that loss is called as expansion. That's why I called as enlargement or expansion, that is denoted by HE. So here also the diameter length is there. So diameter with pipe having length is there, so that's why longer length means friction is there. So HF3. So for third pipe HF3. So again this is called as friction loss and HF3. Then water enter into this tank. So that is exit loss. So that's why indicated by HO. That is exit means HO. So this is the levels we are computing. Now we putting this formula HI, HF1, HC, HF2, HE, HF3 and HO, and then we will get the value of capital H. That is the separated distance between two heights. So that's H, that is HI. So HI means we already know that entrance loss. So entrance loss is known to you, that is 0.5 V1 square by 2G. In previous lecture we have discussed regarding the minor losses. So this is minor loss. HF1 is major loss, so that indicated by 4 FLV square by 2 GD. But section 1 there are 3 pipes, so that's why HF1 is there. So you can write F1 L1 V1 D1 like this. G is constant, that's why you don't write HG1 because G is 9.1. That's why you can take G as it is. Then second term, that is HC. So HC means contraction. So here contraction takes place. So that contraction means 0.5 V2 square by 2G. So this is another formula for contraction. Then next the friction loss is there. So friction loss, that is HF2. So that's why we can write 4 FLU square tau GD for 2 second pipe is there. So we can write 2. Then next plus for HE. HE means again it can go for expansion. So expansion means that smaller diameter into larger diameter. So smaller diameter is V2, that velocity is V2 minus V3. So V3 bracket square by 2G. So this is from enlargement. So initial diameter, that's velocity, and final diameter, that velocity. So V2 minus V3 bracket square by 2G. This is for expansion. Then again length is having length is there, that's why friction loss is there. So this friction loss is computing by 4 FLV square by 2G. For section 3, that's why I can write F3 L3 V3 square D3 2 into 2G plus HO. HO means exit loss. So exit loss is at point number 3. That's why I can write V3 square by 2G. So this is the formula for calculation of the difference in a liquid level is between the two heights. Okay, that is point A to B, or can say level A to B. Again I repeat for these losses. So these are the different losses with major and minor losses. First of all, we consider for major losses. So and minor losses. So capital H is equal to, this loss is called as entrance loss. That's why I can call it as a HI. Then the pipe is long, that's why friction is there. That's why I can write plus friction loss. So that is friction loss. So first pipe is there, that's why I can write as a HF1 because major loss is called as friction loss. So HF1. Again then next go to here, the larger diameter is there, then it should be reduces. So that's why contraction, that's why I can write HC. So HC means contraction. So HC means contraction over here. Then again pipe is long, that's why I can take it as a friction loss. So friction loss is computed by HF2 because pipe number 2 is there. So this is pipe number 2, HF2 plus here again this smaller diameter to larger diameter means what? Here we can go for expansion, or I can say enlargement. So enlargement means HE. Okay, plus again this pipe is again under friction means HF3. So because third pipe is there, so HF3 plus again this pipe is attached to the second pipe, that means exit loss is there. So you can say exit, so HO. So this is the major minor losses we are considering for this series pipe, or can say component pipe, and then put up the value for the major and minor losses, that is HI is equal to 0.5 V1 square by 2G plus 4 FLV square twice GD, that is for section 1. That's why I can write F1 L1 V square by 2GD plus HC means contraction, 0.5 V2 square by 2G plus 4 F2 L2 V2 square upon 2 is GD. This is for second pipe. HE is for enlargement. So here two pipe is there. So first is a section 2 and section 3. That's why we can write V2 minus V3 bracket square by 2G. So likewise we can write for friction losses 4 FLV square by 2G. For section 3 we write F3 L3 V3 and D3 2G plus HO. This is exit loss. That's why I can say V3 square by 2G. So this is the losses we are computing for major and minor losses. Now we can neglect these terms. Neglect this term means we are cancelling this term for HI, then HC, then HE, then HO. So only remains the term after neglecting this term, that is H is equal to 4 FLV square by 2GD 1 plus 4 FL2 F2 L2 V2 square by 2GD2 plus 4 F3 L3 V3 square by 2GD. So this is the minor losses neglecting. So whenever the question is neglecting the minor losses, that means we can write this formula. Otherwise we can considering all the losses. So this is the difference between the major and minor losses we are considering over here. Now we move. This is the friction coefficient of factor for smell. That's why same. If it is same, then F1 F2 F3 is equal to F. You can put like this. So if it is same, then you can put the coefficient of friction F as it is. Okay. Then this is a formula computing for common terms. We can relate with this, and then we relate the H is equal to 4F by 2G L1 V1 square D1 plus L2 V2 square by D2 plus L3 V3 square by D3 in bracket complete. This is for neglecting the minor losses. Now we move for the first problem. Under this chances the difference in water levels in two tanks. So here two difference level we have computed, that is capital H we have determined here, which is connected by three pipes. Okay, so again you have to connect this same pipe that is in series 300 mm length, 170 meter length and 210 meter length, and which is diameter for 300, 204 meter, 400 mm, so respectively. And here that is difference, it is given that 12 meter. That means capital H is given to you, that is catch H is equal to 12 meter. Determine the rate of flow of water if coefficient of frictions are 0.005, 0.0052 and 0.0048 respectively. Here we are considering the first minor losses also. Minor losses also means we are considering major minor losses, and neglecting minor losses means only major losses is there. So this is the difference. So first of all we talk about that given data. So first is difference between the water level, that is 12 meter. Then length is given to you, that is L1 is about 300 meter. Then diameter, then for that purpose diameter is 300 mm. So convert this meter, that is 0.3 meter. Then L2 is given to, that is 170 meter. For that that diameter is 200. That's why I can convert into 0.2 meter. Similarly 210 for L3, that is 210. Then next for that D3 is for 400, that means 0.4 meter. And the friction that coefficient of friction, that is F1 F2 F3, it is given to you, that is F1 is for 0.05, then F2 is equal to 0.0052, then third for 0.0048. That considering minor losses and neglecting the minor losses. So both consider, though both cases is there. So actually this figure is there. This is that two levels, that is A and B is two levels and separated by this distance diameter H. Three pipes were connected here. So first we are considering this all the type of losses, means first loss is your entrance loss, then friction, then here contraction, then again friction, then next expansion, then again go for friction, and here at the end exit. So here all these losses we are computing like this. So this is the figure we are computing, this entrance, contraction, friction, friction and exit. So these are the losses we are considering. This first of all we considering the all the losses. So this is given data already we discussed. Q is question mark because rate of flow is unknown. Now we considering here the minor losses. So considering minor losses means major and minor loss both are considered here. Content equation is A1 V1 is equal to A2 V2 is equal to A3 V3. So from content equation we computing the V1 V2 relations. So first of all we computing for A1 V1 is equal to A2 V2. So A1 here. So this is the losses we are computing here. HI is for entrance, then friction, that is HF1. HC is nothing but for contraction, then again go for HF2 plus HE means enlargement, then again go for HF3, then last is the exit, that is HO. So these are the losses we are considering over here. So first of all, we consider this content equation A1 V1 is equal to 2. So after computing this, V2 is equal to A1 V1 divided by A2. So then again we put this value, and then formulation of this is V2. So V2 is equal to D1 square by D2 square into V1. So already we know that value of D1 and D2, that is 0.3 for D1 and D2 for 0.2. After putting this value, we will get the value of V2. That is V2 is nothing but 2.25 V1. So this is about the first velocity in terms of V1. Then again go for A3 V3 is equal to A1 V1, and for V3 purpose we compute for D1 pi for D1 square divided by pi for D3 square. So come that cancellation of pi 4 over here. Then D1 D3 is we are to put in this value, that is 0.3 and 0.4. So already we have mentioned here D1 and D3 value. Then next about V3 is equal to 0.5625 V1. So these are the value for V2 V3. So V2 V3 is known to you. Then losses, so all type of losses we are considering this equation. Then putting this formula for HI is 0.5 V1 square by 2G. So already we discussed regarding the minor losses. So HF1 is major loss, 4F will be square by 2G. So first is there, that's why we can say F1 L1 V1 square divided by 2V1 into 2G plus HC is 0.5 V2 square by 2G plus 4 F2 L2 V2 bracket square divided by 2GD. So the second diameter is there. Then HE, that is why V2 minus V3, because pipe is smaller to larger, that's why V2 minus V3 is there divided by 2G. So after that we have to put in the value of V2 and V3, because only in term we know that V1 V2 V3 and diameter D1 D2 D3. Okay, we are putting this value. So that's why we comes that 0.5 V1 square by 2G. F1 is given to you, that L1 is given to you, V1 is given to you. V1 is as it is considered over there, 0.3 into 2G plus 0.5. So 0.5 plus 2.25 V1 square bracket square, because V2 value is given to you. Then plus we have to given friction loss. Then we go for the enlargement. So likewise we have to put in the value for F1 L1 F2 L3 V3. Then F3, that is 0.048, L3 is 210. So after putting this all the terms in terms of V1 format, that is V2 value in terms of V1 and V3 also V1, and F3 L3 F3 F1 F2, then putting this value we will get the value of V1. After putting the value of V1 we get the value of V2, right? V2 we can calculate there, and directly we can compute the Q. Q is equal to A1 V1, then pi for D1 square into V1. V1 is already calculated 1.407 and D1 is 0.3 bracket square. So we get the value of discharge. Now we go for this V2 and V3. So V2 and V3 is same because we are using content equation. So that's why this same value is for V1 to V3. So V2 V3 is going to you. Now we go for second case, that is neglecting minor losses. So we have to remove the minor losses, only remain these terms. So we putting the value of F1 F2 L3, then L1 L2 L3 D1 D2 D3, and V1 is terms of V1 as it is, we can keep it as it. Then V2 is 2.25 V1, then V3 is 0.5625 V1. Only that much value we are putting over here, and then after calculation of V1 we will get the 1.445 meter per second. Then again we go for rate of flow, that is Q is equal to A1 V1 pi 4 D1 square, because V1 to is known to you, that's why pi 4 D1 square into V1, and then we get the value of Q, that is 0.1021 meter cube per second. So here we consider the V1, we are considering this A1 V1. Why? Because V1 because we compared V1 value. So that's why you can write A1 V1. If it is V2 is there, then we can write A2 V2. So V1 is known to you, that's why you can write A1 V1. So after computing this value, we will get the value of Q, that is 0.1021 meter cube per second. So this is about the problem related with uh, series pipe, or can say compound pipe. So here there are two cases, one is the major and minor losses considering, and another is for neglecting the minor losses. So we are considering these two losses and computed the different value, that is Q and V1 V2 V3. Now we move for the next point, that is flow through a parallel pipe. So this figure indicates the two or more branches will be there, which is the pipe is divided in two parts. Again, it can reform or can say join together, it form a single pipe. So this branch of pipes are said to be called as a parallel pipe, and the discharge through main pipe is increased by connecting the pipes in a parallel. So there are two branching pipe, pipe 1 and pipe 2. Here already mentioned me that branch pipe 1 and branch pipe 2, L1 D1 V1, L2 V2 D2. Now the rate of flow of main pipe is equal, so therefore the sum of that value is Q is equal to Q1 plus Q2. Write this, because from this figure Q is the main discharge. After that it should be divided into part, that's why Q1 plus Q2. That's why relation we can write as a Q is equal to Q1 plus Q2. Then loss of head for branch of pipe is 1 is equal to loss of head for branch of pipe 2. So this is arrangement because two branching same, so that's why I can write as a like this, and losses will be same, that's why loss of head is the 4FL square by 2G. That's in terms of we can say 1 and 2. So 4FL1 D1 square divided by 2G D1 plus 4FL2 L2 V2 square by 2G D2. So after F1 F2 will be same, that's why I can take cancel out, and after that we can get the value of the formula, that is L1 V1 square D1 GD is equal to L2 V2 square divided by 2 GD2. So these are the formula for parallel pipe. Now we go for the problem. So in that problem, the main pipe divided in two parallel pipes, which again forms one pipe. That means parallel pipe is there. As shown in figure, the length and diameter of our first parallel pipes are 2000 meter. So here length is given, diameter is also given for first pipe, and the length and diameter of second parallel pipe also given, that 2000 meter for second pipe, that is L2, and D2 is for second pipe, that is 0.8. Then find the rate of flow in each parallel pipe. So rate of flow in each pipe means Q is also unknown, Q1 is also unknown, Q2 is also unknown, means branch values also unknown. Then if total value for the main flow, that is Q is also given to you, that is 3 meter cube per second. Coefficient of that parallel pipe is same, that's why we can take 0.005. So first of all we concentrate on given data. So in that given data, already we know that L1 D1 is there, L2 D2 is there. So L1 is 2000 meter, D1 is 1 meter, then D2 and L2, that is L2 is 2000 meter, D2 is 0.8 meter. Now we also know that the value of Q is 3 meter cube per second. Also here given that the coefficient of friction for each pipe, so F1, F2 and F is about 0.005. So these are the same value. And after that we know that the relation Q is equal to Q1 plus Q2, because main Q is their flow and divided in two parts, that is Q1 plus Q2. So main flow is this 3 value, and Q1 plus Q2 is also unknown. Then using the relation for 4FL square divided by 2GD1, because loss of head for branch 1 pipe is equal to loss of head due to branching pipe 2 is same. So after putting this value of head loss due to friction, we will get the value like this, and putting the value of this all the terms, we will get the form of V1 into V2. Now we use this relation for Q1 is equal to A1 V1, and putting the value of pi of 4 D1 square into V1. So D1 is 1, V1 is something that in terms of V2. So after that Q1 is also known to you, that then next Q2 is equal to A2 V2. This is content equation for second pi. So we used here pi of 4 D2 square V2, then then we can put in the value of 0.8 and V2. So as it is V2, so Q2 is going to you. Then again we know the relation that Q1 is equal to Q is equal to Q1 plus Q2, right? Is equal to 3, because Q is already known to you, that is 3 meter cube per second. Putting this value, then we get the value of V2, right? So this V2 value we use for finding the discharge, that is Q is equal to A to V2. So here we have used the formula. V1 is also known to you, Q is equal to pi of 4 D1 square by 4 D2 square. After putting the value of D1 and V1, we get the value of Q1. Similarly, we can go for the Q1, Q2, then we can put the value of Q1 here, and Q is here, then Q2. So likewise, we calculate the Q1, Q2, that means rate of flow for section 1, that means branch pipe 1 and branch pipe 2. So already we calculate this formula, and then we go for this the value. Okay, so this is the required effort, because here parallel pipes known to you, and the discharge, that is Q is known, Q is known to you, Q1 and Q2 are known. For that purpose, we are computing the V1, V2. After that, we putting the value of V1, V2 into of uh, V2, and then we get the value of Q1, Q2, and then Q2 we can directly calculate from the equation. So this is the specialty of the branch in pipe. Now we move for the next terminal, that is hydraulic gradient line. So this total energy line. So in hydraulic gradient line, we are considering the pressure head and datum head. So pressure head and datum head we are considering only in a hydraulic gradient line. So that's why it is defined as the summation of pressure head, that is P by rho G, plus datum head, that is Z. It is flowing through the pipe with respect to reference line. It's obtained by the small vertical coordinate systems, and then we are putting the value, and then it is briefly named as a HGL, that is hydraulic gradient line. Now we move for the total energy line. So total energy line means it is defined as the line which gives the sum of pressure head, datum head, and kinetic head. So all three heads we are considering there. That time the flowing of fluid in a pipe, that time it is called as total energy line. So it is also defined as the, by joining the top of all vertical lines, the showing the sum of pressure head, datum head, and kinetic head. So it is from the center of pipe. So it is defined as a TEL, that is total energy line. So this is the formulation for TEL. Uh, so in that case, HGL and TL, only difference is we are considering the kinetic head in total energy line, and in hydraulic gradient it is absent. So this is about HGL and TL. So in this lecture we are discussed regarding the related with HGL and TL, then parallel pipe and series pipe, that relations and with its numericals.